valedictory session of the Silicon System, a Futurechip Internal Hackathon 2026, organized by the Industry Exploration and Collaboration Cell and coordinated by the VLSI, PZP, and Embedded Laboratories of Banariaman Institute of Technology.
I extend a warm and welcome to our esteemed guest, Mr. Yashwant Muniraj and Mr. Prakasam Ponusamy, whose presence today adds great value to this occasion. I also extend my heartfelt welcome to our respected head of the department, faculty members, and mentors for their continuous guidance, encouragement, and support throughout the hackathon. A special welcome to our dedicated student mentors whose commitment and efforts played a vital role in guiding participants and ensuring the smooth conduct of the event. I warmly welcome all the participants and students who took part in this 3-day journey of innovation, collaboration, and learning. Your presence has made this event truly meaningful, and we are delighted to have all of you here today.
Over the past 3 days, this hackathon has served as a platform for innovation, creativity, technical excellence, and collaborative learning. A total of 71 students across 27 teams participated in 3 exciting domains: VLSI design, embedded systems, and PCB design, the engineering solutions while enhancing their technical and problem-solving skills.
I now invite Dr. Deepa, Professor Academics, for the welcome address.
Good evening, one and all present here. So it's my pleasure to stand before you after this great event. I had 3 days hackathon. In this point of view, I wish to thank the organizers. For the first time, we are conducting such type of event on technology, not on the product or any applications. So we have conducted this event for technology development. This is the base for our students, which will lead our students to have more success in their career. With this, we are delighted to have our guest, two of our guests, Mr. Yashwant Muniraj, a digital and mixer signal design engineer at Analog Devices, with expertise in RTL design, FPGA prototyping, embedded systems, AI hardware accelerators, and hardware software co-design. And he's also an ARM ambassador and actively contributing to the technical education and industry academia collaboration. So we have another guest, Mr. Prakasam Ponusamy, senior software engineer from Visteon Technical and Services Center Private Limited. And he's having over 11 years of experience in automotive software development, and his expertise and industry experience contributed significantly of the development of innovative software solutions and engineering excellence. I think these two expertise, maybe they are the eye-opener for our students, what to do next. I think you all interacted with them, and I thank, in this point, I thank these two experts, industry experts, who accepted our invitations, and they spent their time here for the whole day in judging you. Maybe this will help all our students to get any offers or internships in any core companies. Yes, with this, I welcome our two guests, and also I welcome all our students and professors who maximum they have given their effort to organize this event. Dr. Daniel, Dr. Ilango, Dr. Sajan. So everybody has participated, or they contributed more in this event. So I look forward our students to take over this part, and you need to participate in more such events which will be conducted inside and outside the institute. And also I wish all our students should be capable of organizing such type of events in future. So with this, I welcome you all for this event, and maybe we'll listen to the speakers more for their inputs. Thank you all.
Thank you, ma'am. Thank you so much for setting the tone of the day.
We are delighted to have our esteemed guest with us today. Mr. Yashwant Muniraj is a digital and mixed signal design engineer at Analog Devices with expertise in RTL design, FPGA prototyping, embedded system, AI hardware accelerators, and hardware software co-design. He is also an ARM ambassador and actively contributes to technical education and industry academia collaboration. I now invite Mr. Yashwant Muniraj to share a few words with us. Please, sir.
A very good evening to all of you. All of you are tired or energized after 3 days of continuous hackathon. So I'm visiting BIT for the second time. I visited, I think, about a year back or something. So there is only one reason, I decided to visit again in spite of my very busy schedule. I'm on travel, all travel next week also. But the only reason I visited again is because the last time I visited, I saw the energy, the excitement, the dedication, and the effort that the faculty and the students put into what they do here. And that's the only thing that motivated me to come again here. So I like to brainstorm, think hard, and then work your way into whatever you're doing. And last time when I had this college visit, I realized ki BIT is doing something really great that most of the colleges are not even focusing on, right? They just leave their students to do whatever they want, and some of them pick up what they're interested in and they eventually get into what they are, but then other students are just left clueless mostly. But BIT is doing something different, so that's what interested me to visit again. Coming to this hackathon, so the theme Silicon to System is personally close to my heart because that's the day-to-day work I do. I joined Analog Devices as a firmware engineer, as an intern actually, developing a product and doing firmware, and then I transitioned into embedded software engineering, and then eventually transitioned into digital and mixed signal design, right? So I have seen how you go from a system specification, that is a PowerPoint or a whiteboard, to actually a working silicon and then writing software and bringing it up in the lab. So that's why I said this is very close to my heart. So let's talk about the hackathon itself a little bit. So from the 3 tracks we had, VLSI, embedded systems, and PCB design, I personally was able to evaluate VLSI and embedded. I didn't have time to view the PCB design part, but I got the feedback from the other guests that it was also pretty good. So here's something I would like to share on VLSI design first. The idea for this hackathon is really good. The 8-bit computer that you all built on, and I really appreciate you guys, putting all the effort to do it within 3 days, which is astounding, right? I don't know how you guys were able to do it within 3 days because it's really a big effort. So one feedback I'd like to give is when you start working on something, try to think from different angles. The way that now, let's say you're building a processor, right, a computer. So first of all, see if it's what type of architecture are you trying to build. Is it a CISC or a RISC? Or what other type of architectures do you have in processors, right? And try to understand what different things do. So that is very important, firstly. You also have von Neumann and Harvard architectures. I think that is something some people couldn't kind of understand completely. So I would say try to understand what it exactly is. You can just search Google or do a Wikipedia, right? You will get what the difference between those 2 architectures are. And then when you write logic, right, when you write RTL, you're writing RTL code, don't just write in the sense that, if I write a statement and then this variable gets assigned to this, or this is a blocking or non-blocking, this will come in the next cycle or something like that. Think hardware. When you write RTL, you should know what hardware it is going to synthesize, because I noticed, the Beniter's computer actually had a tri-state bus. It made sense because on PCBs or on breadboard you can have a tri-state bus architecture, but on an FPGA you generally don't have tri-states, and tri-states have been eliminated from the 1980s or 1990s when microcontrollers started emerging more and the peripherals started becoming on chip instead of being on board. So that is something that you have to think and realize what is actually going into my FPGA. So think hardware. If you're writing a code, see if it's going to be a mux, it's going to be a flop, or it's going to be an adder, or it's going to be a multiplier, or what it eventually gets into in your FPGA. So that is very important because it'll be easy to crack interviews in future when people ask, oh, you write an RTL code, what is this doing? What it eventually gets into, right? So that is very important. And then try to understand the complete flow, what happens in synthesis, implementation, your bitstream generation, placement, not just the FPGA flow, also the ASIC flow. For bachelor level, I will not say you have to understand the nuances of every process, but just have an overview of what happens at each and every process. So that's all I had for VLSI. Really great job, guys. I'm really surprised by the effort you guys have put, and to actually see the processor working and executing instructions is really amazing. Coming to the embedded systems part, again, I think almost everyone had their software, UART, SPI, and I2C working, and most of you were able to tell me what is clock stretching and what is bus arbitration in I2C, and what you do in case you don't get a knack, and all of that. Really, really amazing. And in terms of embedded systems, again, right, try to go a little more deeper into the hardware on what happens. If, for instance, I was asking people what happens when an interrupt triggers, right? You have an IRQ. What exactly happens when a peripheral is interrupting the core, right? What is the complete flow? If you have an interrupt line which is connecting from the peripheral to the processor, the processor has different IRQ lines. And once the IRQ line gets asserted, what happens to the software running, right? What happens to the program counter? What happens to the stack pointer? What is your main stack? What is your process stack? And then how your interrupt eventually flows, and then how your interrupt returns to the main program. So try to think more deeply into hardware when you're working on embedded systems. And even processor architectures are important for embedded systems also. For instance, I asked people, is this a CISC or a RISC? What is the exact difference, right? What is microcode? What type of processors are there in your mobile phones, in your laptops, in your desktops, in your servers, and stuff like that. So try to think, Google it, be curious in knowing what is present in your day-to-day devices also. That is also very important. PCB design, I personally could not see due to time constraints, but I believe you all have designed for PIC microcontrollers, and you have designed power supplies and interfacing peripherals and stuff like that. Great work. And so here's a proposal for what to do next. So in this hackathon, I see we going from silicon to system, right? You had VLSI, which is the first step, and then you had embedded systems, you wrote firmware, and then you did PCB design, where eventually your processor, whatever, goes into, and all of that. But one thing I saw was that there is a slight disconnect from people, working on VLSI, embedded and PCB design. For instance, let's say someone designed a processor, but then you are writing, I think you all were working on a CISC processor, but the embedded systems guys were writing code for a RISC processor. And then PCB again was maybe using some other controller, not STM32, maybe a PIC or something. I'm not aware. So what my proposal is, when you form the teams, make sure that the VLSI design team in future, instead of a hackathon, we make it a marathon, right, which is a little long running, so that each team will work together, so that you go from one phase to the other and it's all connected together. I'll give you an example. I think you guys are already doing tiny tape out, right? So go for a design specification, go for the design first. The VLSI design team, the embedded systems design team, and one team from each team, work together, and then they finalize what should be the silicon, what should be the PCB, what should be the software. So that's how real industry works, right? So for instance, I was actually leading a firmware called manufacturing test firmware. I used to work with design verification, analog design, mixed signal verification, PCB design, applications, product test engineering, design evaluation, post-silicon validation, all the teams together, right? We collaborate and work together. So I want you all to collaborate, one team in each team, collaborate together, decide what the system will eventually be, and work together towards, a bigger goal. Because, a 3-day hackathon is very good, but when it comes to, industry, people expect something bigger, right? You've worked on for a longer time, a bigger goal. So that is one suggestion I would give you guys. And coming to the judgment and winners that are going to be announced, right? Uh, I would congratulate whoever won the prizes. But then at the same time, for those who didn't make it this time, don't worry at all, because when you talk about silicon, the first silicon rarely passes. We always have second tape out, third revision. For instance, all the silicon in your mobile phones you have are probably like, sixth or seventh revision, or maybe even eighth revision, we don't know, or maybe fourth or fifth revision, right? Because first silicon rarely passes. So keep trying. You don't have to, win the first time, right? So that's how the industry works. And I really appreciate all the organizers, the faculty members, the management, for giving students this opportunity and actually, making this happen. It rarely happens in colleges these days, right? And I think BAT is definitely an exception in that case. Thank you for having me. Thank you, one and all.
Thank you so much, sir. We will take your inputs and work better together for the future. We also extend a warm welcome to Mr. Prakasam Ponusamy, Senior Software Engineer from Vision Technical and Services Center Private Limited, a seasoned professional with over 11 years of experience in automotive software development. His expertise and industry experience have contributed significantly to the development of innovation software solution and engineer. I now invite Mr. Prakash Ponusamy to address the gathering.
Good evening, everyone. I think you guys are almost spent 3 days in this hackathon, as we all know. Yeah, it's actually a new step from BAT. I am really happy for that, and you guys have made an amazing, work done all together. I think, many of us, I have only heard about SAS hackathons and other hackathons, and only software guys will do hackathons. All those things are myth nowadays. Okay, you guys are made a really good amount of effort, and you guys have done very good, fabulous work. I feel very good about all of us are very interesting in doing some effort on your core technology, correct? No? Like developing a PCB board, or spending writing some code on embedded software development, or thinking more about silicon and making some chips, irrespective of using available microcontrollers or microprocessors or some other sensors or other things. I feel I am really feel good about part of this hackathon evolution and part of your discussion made with you guys. It was very good. So I have already given some feedback for then and there with embedded guys and with PCP1, and already one of our guests already given enough inputs for you guys. My suggestion, so whatever you learn, you just try to connect your dots with all the other core topics as well. So when you say semiconductor, you just take it from what is semiconductor, insulator, and how it works, and what are all the materials we are using it, what are all the revolutions are going in the material level, and how this semiconductor becomes a chip, how these chips are used in different industries and application areas, why do you want to make PCB boards, and all this you try to have better connection, so that you can, as you mentioned, it can be one hackathon or one marathon, so all you guys can build one particular product or one particular work. So for each discipline people, one from the PCP, one from the embedded, one from the VLSA, can to be a one team, or you guys have 5 to 6 people as a team, and you can work for one product as a 5 days or 6 days session, and you can have completely, you just make a Gerber and build it. and try to take embedded PCB can be possible. So we don't want to post silicon process all the steps he was explaining. No, you want to make silicon and then post silicon process and then driver development for post silicon, and then that can be a microcontroller or ASIC, and that can be used in a PCB board. So it's all you guys are well aware about, but yeah, connecting these dots and connecting your basics and having some vision or idea about which industry are you going to target, either the avionics industry or the embedded system industry or the medical electronics industry, which one is you guys are going to target, have some more idea or some kind of strategies. When you are in college itself, you guys are doing amazing work, so try to have some more data gathering. Now you have very good AI tools, correct? So whenever you want to know something, whenever you want to explore something, you can ask your AI tools and it will give you some set of ideas. So you can again brainstorm on those ideas, and you can get to know what the industry is doing currently and particular domain, and how you can able to improve your skill sets towards the domain. That is also you guys can do it. That is my suggestion. Apart from that, yeah, you guys have a very good determination and fabulous work. You guys have done it for the past 3 days. Yeah, it's really, I'm really happy, because many of the colleges are not doing this much effort from the faculty side as well as student side. Yeah, it was a collaborative effort from you all. Yeah, we are really happy for that, and thank you so much for the opportunity. Yeah, thank you.
Thank you, sir, for your encouraging words and valuable guidance. Now it's time for our felicitation. I now invite Dr. Deepa, Professor Academics, to honor the guest with a memento. Thank you, dignitaries.
One of the greatest achievement of any hackathon is the learning experience it provides. To hear directly from our participants about the journey, challenges, and key takeaways, we now invite student representatives from each team to share their feedback. Feedback from VLSA design student.
Good evening to one and all. I'm from VLSI design team. And first of all, it was really a highly enriching experience to participate in this hackathon. And also at the beginning, we thought that it was really difficult to build an FPGA implementation of 8-bit SAP computer. But the timing constraints and the environment made this. Also, this hackathon, I gained hands-on experience and other technical skills. And special thanks to our mentors who mentored us. They really guided us step by step. We could make this succeed. Thank you.
Thank you so much. Feedback from PCB design student.
Good evening, everyone. I'm from PCB Design. So, first of all, I thank organizers for organizing this wonderful hackathon. So, from this, I have learned so many experience about PCB. From till now, I don't know about PCB this deep, but after participating in this hackathon, I have gained so much knowledge about PCB. So, I come to know about PCB component selections, layout design, DRC, and etc. etc. So this hackathon helped me how to find how to find ways to solve the problems, and to manage team communications and etc. So I sincerely thank you for everyone for organizing the hackathon.
Thank you for sharing your valuable experience and insights.
A successful hackathon is made possible not only by enthusiastic participants but also by dedicated student mentors who guide, motivate, and support students throughout the journey. As a token of appreciation, we shall now distribute certificates to our student mentors. I kindly request our esteemed guest to present the certificates. I request Navneet Prasad to come forward. to collect your certificates. I request Mr. Muhammad Riyaj to join them. I request Akash P, student mentor, to receive the certificate. I request Vikash R to receive the certificates. Let us give them a well-deserved round of applause for their valuable contribution to this hackathon. Thank you so much. We shall now begin the certificate and prize distribution for the VLSI design theme. Now, we move to the third prize of VLSI design. Third prize goes to Kirubagaran S, Santosh V, and Linkeshwaran S. Please make some noise for them. They received the cash prize of rupees 2,000. Second prize of VLSI design goes to Rahul Sivesh S, Praveen Hari GS, and Indra Priyadarshini. They received rupees 3,000. Give them the big round of applause. Any guesses for the first prize? First prize of VLSI design goes to Dhanashri A, Kavin V, and Mohana Priya. Give them a big round of applause. Congratulations. We also request all the participants of the VLSI design team to come forward and receive their participation certificates. Meenakshi E, Tarun S.A., Janadani S.K., Naveen Raj S., Harini M., Adash D., Durai Murugan, Vasan, Arut Selvan, Bel Murugan, Harish, Muhammad Shakil, Madesh, Sabarinath, Naveen, Kavina, Ilamadi, Jeevita, Sujita, Mehantia, Shivashankari, Pon Kirtika, Monisha. Please stand together for a group photo. I request the participants of VLSI Design to stand near the stage. Please come together for the photograph. I request all the participants to come forward for the group photo. Please get into the stage.